Hey guys and girls, welcome back to another beautiful video on this beautiful channel on this beautiful day. How you guys and girls doing? Oh my god, oh my god, oh my god. So this is a really important video that I'm gonna make, and it's not gonna be that good. Alright, you're probably still gonna have to go on your own and read about this because I'm not that good at this. But let me just say what it is first. It is the graphics pipeline and how the graphics card and the computer actually work to produce graphics, right? So just a really basic introduction, because what we're going to be doing in the next video is creating our shaders. Now you're like, what the hell is a shader, right? Now I'll explain as much as I can in this video. So let's start off by saying this: like everything you do, like in our tutorial, we're going to start by making a triangle. All right, now this triangle has 3 points, and points are called vertices. All right, a vertex is a point in space with 3 coordinates in our case, because it's a 3D vertex, right? So it has a x, y, and z position. Now these vertices are just points, but there can be vectors created between these, right? See? And my arrows are kind of weird, so but there are arrows here and they have a direction. Now remember what I said, vertex or vectors have directions. So this can be made into a triangle with lines. All right, now the vectors here are important because there's a certain order in which they're drawn. So there's clockwise and counterclockwise, and we'll get to that. We can set these options in OpenGL later, and this decides which side of the triangle is the front and which is the back, because often we don't want to draw the back of a triangle because we won't see it, so we don't want to waste the time. So we just want to draw the front, and that's why these vectors are important. But nevertheless, these are points, right? Just remember there are points here. Let me make those red. The vertices are red here. 1, 2, and 3. Now what happens in the graphics card? Now these vertices are on the CPU, right? They're in your program, in your C++ code. We haven't sent them to the graphics card yet because they're just as 3 GLM vec3s, which we're gonna see. There's just vectors with x, y, and z coordinates. Now we want to send them to our graphics card, and we're going to do that by sending them using a function, a buffer basically. Now our graphics card has its own RAM memory, right? This is in our CPU RAM, computer's RAM, and we want to send all this to the GPU RAM. But so that's what's going to happen. We're going to first set all this data to the GPU, all right? GPU. And we're gonna kind of define in which order, because each of these vertex has a position, color, and a texture coordinate, let's say, or just say position and color right now. I want to say in what order we're gonna use these 2 coordinates. So the first 3 floats are gonna be the position, and the next 3 floats is gonna be the color. And then after 6 floats we have another vertex, which is 1, 2, 3 position, 1, 2, 3 color, because the GPU doesn't really know anything about that. It just sees a big array of a bunch of floats coming in, just one after another from all of these points. So we have to kind of tell it how we're going to use these floats, how much of it is what. So we're going to do that. But once we've done that, we'll see that in the code in the future videos. This is just a simple explanation anyway. So once we've done that, we're going to go through what's called the graphics pipeline. Now everything starts in the Vertex Shader. All right, it's called the Vertex Shader. All right, now the Vertex Shader is a very important thing. Now let me just say one thing. In the GPU, this is a GPU, all right, there's thousands of cores. Our CPU might have 4 cores, 6 cores, but the GPU has thousands of cores, right? And in each core you can run a little program called a shader. Now shader doesn't just shade something, it's just called a shader, but you could call it the vertex program or whatever. This program is run in all of these little cores, and a vertex shader is run once for each vertex that we're sending in. For this model, if we're sending in this big model with 3 points, vertices, into the GPU, the vertex shader is going to be run 3 times. All right, one for this, and one for this. Now the vertex shader can change the stuff we're going to be sending in. We're going to be sending in the position and the color. So we could change those or just send them on to the next stage. Now there are more stages in between, the tessellator, all that stuff, but I'm just going to say it sends it into the Fragment Shader. But there's another shader we'll talk about later. It's called the Geometry Shader, which is a step between. But we'll just go to the Fragment Shader directly. It's called the Fragment Shader, whatever, blah blah blah. Now a fragment is a representation of a pixel. So the Fragment Shader, you imagine your screen is this big, right? It has thousands, 1920 times 1080 or whatever pixels, right? This is gonna run for each of those pixels. Now the Vertex Shader is gonna send in this beautiful triangle, and each pixel in between this, sorry, I said that wrong. There's a bunch of pixels, but our triangle is gonna be in here. All right, Fragment Shader is gonna run once for each pixel, each fragment in this object. So it's gonna kind of calculate how many pixels are in here, and it's gonna be run once for each fragment. Now that's how we can shade stuff and do cool stuff. So it's sent in there, and the color is sent in, the position is sent in our case. Position isn't really important here, but we can send it in if we want to calculate some cool lighting effects and stuff like that. But the color is important. So each vertex, this vertex might be red, this vertex might be green, this one might be blue. And we're sending in a red, green, and blue vertex here. But here there's maybe hundreds of fragments. So why are these three colors, how can they turn into all these thousands or hundreds of colors? Well, that's something called interpolation. So every fragment here, we're gonna get a color from this vertex, this one, and this one. There's gonna be a mix of those colors in between. So every fragment up here is gonna be red, every fragment around here is gonna be green, and here are blue. But everything in between is gonna be a mix of all of those. It's gonna be interpolated, so mixed kind of automatically in a way. And everything you send in from the Vertex Shader to the Fragment Shader can be interpolated. Positions, all that stuff. Yeah, so a fragment position can also be found, right? So you can get a position of a certain pixel in the object while you're running this. All right, so that's really important to note, and we'll see how all that works in code later. So that's basically a graphics pipeline. Then all that is sent to something called a rasterizer, which takes your perfect vectors and kind of makes them into pixels. So it kind of prints that out on screen as a kind of jagged triangle. That's why you get aliasing, all right, in games, and you use any aliasing to kind of mix those edges and blur them to make it look more sharp, crisp. So yeah, that's why you get aliasing, because you're kind of trying to represent this perfect triangle in pixel format with small squares and stuff, right? So yeah, that's basically it. A shader is a program run on the GPU for either for each vertex or each pixel in that model, right, between the vertices. So yeah, that's basically it. It's just a real short intro, and it's good to know, and I hope it gets clear as we go. This isn't a beautiful drawing, and I'm not that good at drawing, but I'll draw you a cat while I talk, because this is how you're probably feeling right now, and just pissed off because I don't know how to explain this. But my recommendation is to go to learnopengl.com, check out their tutorial on it, read a little bit more about it. Go and Google the graphics pipeline. All right, a graphics pipeline, check it out, and just go through that, and I promise you, you'll be a lot better at it. And yeah, thanks for watching, guys and girls. And the next video might be a little complicated with the shaders, but at least you'll know kind of what it does. So yeah, thanks for watching again. Take care, keep learning, and I'll see you in the next one, right? Bye-bye.